So in this video, I will be explaining question 1 of homework 9. So let us first look at question 1. So we are given a WT, a stochastic process, and we are also given that the expectation of WT is equals to 0, and also the autocorrelation of W is alpha into minimum of T1 comma T2. So we define a new stochastic process which is y of t equals to W of t minus W of t minus 1 for t greater or equals to 1, otherwise it's 0. So we are required to find out expectation of y of t and autocorrelation of y. So let us look at the solution. So we see that yt equals to wt minus 1 for t greater equals to 1, and it is 0 for t less than 1. So expectation of yt can be broken down into as this, that is expectation of wt minus 1, which is nothing but we can distribute the expectation. So expectation of wt minus expectation of wt minus 1, which is nothing but 0 for t greater equals to 1, and also expectation of yt would be 0 for t less than 1. So expectation of yt is equals to 0 for any t. So now we are about to find out the autocorrelation of y. So ry of t1 comma t2 can be written as expectation of yt1 into y of t2. So we put the values of yt1, that is w of t1 minus w of t1 minus 1, and w of t2 minus w of t2 minus 1, and we multiply them together distributively, and we get that this simplifies to alpha into minimum of t1 comma t2 minus minimum of t1 into t2 minus t1 minus minimum of t1 minus 1 comma t2 plus minimum of t1 minus 1 comma t2 minus 1. So now from this equation we see there could be four combinations of t1 comma t2. So first let us look at when t2 is less than t1 and t2 is also less than t1 minus 1. So if this case happens for the first part minimum of t1 comma t2, that is t2, then for the second part t1 comma t2 minus 1, so this is also t2 minus 1. For the third part t1 minus 1 comma t2, we see that t2 is less than t1 minus 1, so we have again t2. And for the last part t1 minus 1 comma t2 minus 1, we see as t2 less than 1 t1, so as t2 minus 1 less than t1 minus 1, so this is again t2 minus 1. So everything cancels out, and we find out that autocorrelation of y is 0 if t2 less than t1 and t2 is also less than t1 minus 1. Now let us look at a second case when t2 is less than t1 but t2 is greater than t1 minus 1. So what happens in this case? For this case t1 minus 1 comma t2, so the minimum would be, so we see that t2 is greater than t2 is still less than t1. So for this first part t1 comma t2 we put t2. So for the second part we see that t1 comma t2 minus 1. So as t2 is less than t1, so t2 minus 1 would obviously be less than t1, so we again put t2 minus 1. Now for the third case t1 minus 1 comma t2, we see that in this case we have assumed that t2 is greater than t1 minus 1. There it is. So the minimum would be actually t1 minus 1. And for the third case where it is given that t1 minus 1 t2 minus 1, so we know as t2 is less than t1, so as t2 minus 1 is less than t1 minus 1, so this is again t2 minus 1. So cancelling out everything, we found out this simplifies to alpha into 1 plus t2 minus t1, or otherwise alpha into 1 minus t1 minus t2. So if we consider all the cases, then we will have autocorrelation of y, that is ry of t1 comma t2 would be 0 if mod of t1 minus t2 is greater than 1, or otherwise alpha into 1 minus t1 minus t2 if mod of t1 minus t2 is less equals to 1. So as we see that the autocorrelation of y only depends on t1 minus t2, so yt is also a wide sense stationary stochastic process. That's all for this video. Thank you.